So now we have a secondary user, so we're going to connect to our secondary from our primary, right? So the secondary is going to be like the target machine, and the primary is going to be the machine that we're going to connect to from primary. So the next thing that we need to do is we need to come over to primary, and we're going to do it from Ubuntu. And the first thing we're going to do right now is we're going to say SSH keygen -t RSA. So if you have ever done like SSH keys for GitHub, this is the same process, right? Why would you do this? Well, why does Git do that? It's because Git is using SSH underneath the hood to connect. So what is an SSH key then? An SSH key is this like cryptographic key that basically creates a private version and a public version of it. The private version you never reveal to anyone. That's like kind of like your secret. And then you give your public version to people. And then using the private version and public version, it allows services to do a handshake with each other, that they never have to reveal their private keys, but they can verify that the other party has the private key that they say they have. I'm not going to get a lot more into the cryptography of it because, frankly, I don't understand that much math. But it's very interesting. It's actually worth looking into. I actually left a link there so you can look into the Diffie-Hellman algorithm, which is kind of like the first asymmetric cryptographic algorithm that came about in the 70s from two computer scientists. I think they were at Berkeley. Most things come out of Berkeley, named Diffie and Hellman. That kind of like revolutionized how we do cryptographic handshakes. There's like, yeah, it's super interesting. So that's what this is we're going to generate that private and public key. This public key we're going to give to the secondary, and then the private key remains on the primary, or the private key remains in the primary, and we never reveal that to anybody. And then RSA is just like the particular flavor of key that we're going to generate. Okay, so we're going to generate a public and private key. It's going to save this in SSH ID RSA. That's exactly what you wanted, so you're just going to hit enter. You could put a passphrase here. For our simplicity's sake, right now, we're not going to put a passphrase because it would require you to enter a passphrase to ever use this key. Typically, you should do that. Like, for example, if you're on Mac, you should generate that, and then you could add it to your keychain so it automatically goes in afterwards. For now, let's just not put one. Okay, so now we have this key. So if I go into my .ssh folder and I look in here, I have an RDSA and an RDSA pub. This one is the private one, the ID underscore RSA, and the one with pub with it is the public one. So never reveal the private one to anyone. And this is the pub one is one that you give away to other people. If you accidentally reveal your private one, delete the file, regenerate them, because at that point you can just consider it compromised. And it's also really, I just showed, like it's very easy to regenerate them, so don't worry about that. Okay. So let's go back to secondary. If you're not already logged in as your secondary, like the Brian, say switch user Brian or whatever you named your user. I'm already logged in as Brian, so I don't need to do that. And I'm going to make a directory of .ssh. So now, if I look here in my home directory, you see I have a SSH directory, so I'm going to cd into that. And what I'm going to do now is I'm going to vi a file called authorized keys. Okay, I'm going to come back over to this one, and I'm going to cat out my ID rsa.pub, and you're going to copy everything from this, including the Ubuntu at primary part of it. Okay. Now we're going to go back over to this one where I have it in VI. I'm going to insert and paste that in here. And this is basically going to say, here is a public SSH key that if someone can verify that this is their key that they have with their own private key, allow them to log into this computer. So it's basically like the key, the username and password for this user. Okay, so I'm going to right quit that. I'm going to have to sudo chmod this to be, and I'm going to do it for the directory. So, and put in the password. Oh, Brian's not a, can I just do this without ch or sudo? I can, cool. Cool. So I made that SSH one read, write, and execution for just the user. And I'm going to chmod 600 SSH / authorized keys. So now it's locked down to just this user. It's not anyone can go in and read these keys, which is also good to have as well. Okay, so what we've done so far is we generated SSH keys on the primary so that the primary can connect to the secondary, right? And that we took the keys from the primary, the public key, and we moved that to the secondary server so that when this primary and secondary handshake with each other, they can verify to each other as like, you have the same key set, right? That's kind of what's going on here. I guess you can kind of think of it as like the private key being like an actual key, and you can think of the public key being like handing someone a lock and saying like, I have the key to this. You can display this lock on your front door that everyone can see that lock, but only the person with the key can unlock it with their key, right? That's, I think, mostly analogous. I'm sure someone's sitting there thinking, well, actually, it's not that, which is fine. You can tell me in the chat or tweet at me or something. Okay, so that's where we're at right now. So everything is all set up now. We need to get an IP address from the secondary so that the primary can connect to the secondary. So if I say ifconfig here, ifconfig, I actually end up using this command a lot. This actually will just show you a bunch of information about the computer's place on the network. So you can see here it prints out a bunch of numbers and broadcasts and net masks and that kind of stuff. I don't know what half of these means, but the one that we're looking for is actually this one. 192.168.643. So this is my network address on this network that I'm on at the moment. And the network in this particular case is it's a fabricated virtual network on my computer that Multipass has created. It's not even Multipass. I could actually access this from Mac OS, right? So it's actually the network on my computer. This one down here, you can see this inet here, this 127.0.0.1. That's a special address that's called the loopback. So it's how a computer refers to itself. So you've probably seen like those mugs, like there's no place like 127.0.0.1. There's no place like that would be like your home, right? So you can even see it says right here, local loopback. So that's how a computer can refer to itself as an address. This one here, you can see that it says Ethernet. This is actually like the real network address. So suffice to say, the one that we're looking for here is 192.168.64.3. Make sense? This one's an interesting as well. The net mask here, 255, 255, 255, means that these first three numbers are locked in, like they actually can't change for this particular network. And you can see the broadcast is 192.168.64. That means that's going to be those numbers that are locked in that won't vary for this network. And the .255 here means that this is the number that varies. So if we look at the various different numbers, it's only varying on that last number. And then I think this inet6 one is the IPv6 of it. I never used those, so I actually really not totally sure. Anyway, here we go. So grab this inet, this 192.168.64. Yours might be different than mine. It might be the same. I'm not sure. But this is the number that you're looking for right here. Okay. And now, let's see. What should work now? This was on secondary, so I got the IP off of secondary. I'm going to come back to my primary, and I'm going to say SSH Brian at that number. it's going to ask you, is like, are you sure? The reason why it does this is if the computer, like the actual physical server, changes underneath you, you'll know. So this key is actually exchanges like, hey, I'm this server. Do you know that you trust this server? And if you say yes, it's going to store that on your computer and say, in the future, it's going to check that every single time to make sure you're connecting to the same server. And if that server changes, it's going to say, like, hey, something changed. This is not the same computer I was connecting to before, and it won't let you until you resolve that situation. And you can see here, by doing that, I have now SSH. So I have my primary computer that's going over the network and connected to the secondary. And now we have set it up SSH. So again, I can just say exit, and that will drop me back to Ubuntu, and I can reconnect as much as I want. Pretty cool, right? So that's how you set up SSH. It's actually quite easy for the most part. Our Ubuntu is already running the SSH agent, so there has to be something running in the background that accepts these requests. And by default, I think Ubuntu in general just runs that by default. But sometimes in some distributions, you have to go in and install all the correct SSH agent stuff and get that started and running. I'm not going to show you how to do that. You could very easily Google how to do that, but it's cool because we don't have to know the password or anything like that. Just by virtue of having those keys, we can set it up, and it's really easy. So like I do this stuff all the time whenever I need to connect to a VM. So here in secondary, if I go into my .ssh folder, you can see I created this authorized keys file, right? And if I vi this authorized keys file, this is the public key from the primary, right? So I pasted that in there from the primary. So I generated that key on the primary, I copied it, and then I pasted that into the authorized keys on the secondary. So now this key, whoever has the private version of this key can log in as this user using SSH. So the reason why this is authorized keys is because you can have multiple different users being able to connect to it. So I could create a tertiary, right, VM and also paste its keys in here, and it could also log into this as long as its public key was in here. If that makes any sense. And that's really as complicated as it is. There's not any more to it. No.
Can you set up a third computer to also SSH into secondary? And would you just add another public key into authorized keys?
Yes.
Yeah.
Cool.
Is the process the same if I want to connect to a VM running on VirtualBox while I'm running Linux natively?
The process will be the same. If you're doing this through VirtualBox, you would stand up a second VM, so like a second window that's running a separate VM. The only thing I'm not positive about, and I haven't tried, I think it should work, is you have to make sure that those two VMs end up on the same network, right? They need to be connected to each other in some capacity. I think VirtualBox does that by default, but I'd really have to check. Yeah, like if you were doing, you could also do this with Docker, right? And in some capacity, Docker kind of does some of this stuff for you. But you would need to make sure that they ended up on the same virtual network. So yeah, that's the only thing to double check. If you want to do this using VirtualBox, just make sure that everything is on the same network.